Here we are. So yesterday we had that persistent memory. What was the actual title of the BoF as advertised? Anyway, I'm just going to call it the Persistent Memory BoF Update. It was held here at about 5 o'clock yesterday. We had a lot of attendees. It was a pretty full room. I'm going to estimate about 50 people came over the course of the thing, so that's quite the BoF. We were very pleased with that. And we had an incredibly lively discussion. It went quite deep and quite broad. I was real happy with all the things that we talked about because this is as I mentioned in my presentation on Tuesday, this is a really broad thing. It encompasses APIs, applications, RDMA layers, platform issues, and actual persistent memory technology. So it goes up and down the stack, and it's a really broad and, in the end, going to be a complicated topic, one which will require a lot of people to contribute to. I led it. Stephen Bates he and I had planned to do it together. I don't know if you know Stephen Bates, but he's been he's at Microsemi, formerly PMC Sierra, and he's been working a lot with peer-to-peer persistent memory transfers. He and Mellanox have this prototype that shows a Mellanox card transferring to this PMC Sierra memory card without any CPU interaction whatsoever. So it's a really interesting model for where we want to get with low latency storage. Unfortunately, Stephen wasn't able to attend due to personal reasons, but he's here in spirit. So I'm just going to run down 4 slides that show our main discussion points. And you're going to find there's a lot of points on here, which, as I said, is a really good thing. But just to kind of recap them, keep everybody on the same page. Everybody agreed that there was a need or a very strong desire for an explicit remote commit operation of some kind. I didn't hear any dissension whatsoever to that. So that's great. Let's latch the first notch on the ratchet and say this is something we want, right? This is something to pursue. But as soon as you go there, all of a sudden a lot of questions start to pop up. Many of these things have already been discussed, and now they're being discussed again. As I say, the broader and broader, the better. The first and maybe most interesting was what's the scope of the commit? If you do a commit, what gets committed? Is it everything, the whole system? Is it everything I sent on this connection? Is it a single region? Is it multiple regions, a scatter list? Is it explicitly tagged? Can each write have some sort of transaction ID? These were all explored. I believe the multiple region offset and length option is preferred by most models. It's certainly preferred by the upper layer APIs, but limits were interesting. Ordering and fencing, does commit impose an explicit fence? That was a really interesting discussion. Or should the fence be specified by the initiator? Should the initiator push things that need to be fenced? The ordering of a commit with respect to other writes is very important to applications. And so I think we have to think that through. What other ordering is desirable? We've already talked about the log writer scenario where you write a log record and then you atomically update a pointer to make that record the current record. That's an obvious one. What are the others? Is there an alternative to commit? Can RDMA writes be decorated instead? We had a lot of discussion about the pros and cons. I think this one will be discussed quite a bit more. I believe there was a consensus there were more cons than pros to the RDMA write decoration. I personally agree with that, but I think it's important that we discuss it. Decorated meaning some sort of push mode on an RDMA write that says, when this write is placed, commit it durably. We can talk a little bit about the detail. I just want to make sure we get through this without delaying the agenda too far. Discussion then continued, piggybacking and aggregating commit responses. Is there any way to sort of acknowledge multiple commits in one reply? It's seen as a potential optimization, certainly something that transports can do. Maybe the applications can make good use of it, but it doesn't fundamentally alter the model. So we sort of agreed to, push that to a second order discussion. Ordering across ranges. How does a commit to region A affect a commit to region B? This is partly the fencing question. It's also an ordering question. Which goes first? What guarantees are made when? How can an upper layer use multiple connections? Can I write on this connection and commit on this connection for efficiency? Consensus that these points are important to explore. This sort of cross connection ordering is interesting. Ordering on an unordered transport. Well, can we put this on a datagram transport? Is that possible? How would that happen? What would change about the requirements? And will upper layer push mode contribute to incast congestion at the PM? If we have all these clients all doing write, commit to a single node, will congestion occur at that node? Well, probably yes. What does that mean? How do we work around that? Can crediting and QoS policies apply? Is push mode the only model to use? We had a good discussion about that. Moving up, relationship to existing APIs. There was a lot of discussion about the SNIA NVM programming library, which has been like two and a half years in the making. Very mature API, the open source implementations of it. It's a powerful model for where we want to be, I think. Windows and Linux mapped files. Both Windows and Linux are taking the same approach to exposing PM as a mapped file. Map view file, flush view file in Windows, mmap msync in POSIX. They both use a load store, a native instruction paradigm for populating the data in the file, but then an explicit flush, right? Either flush view file or msync to actually push that data to durability. And so there's some certain natural mappings, but they favor the model of an explicit commit is the argument, or was the slight conclusion, maybe not a definite conclusion. More discussion. But another interesting question around that was, is an asynchronous commit useful? And the answer was, yeah, probably. The SNIA NVM twig is actually already thinking about this. This might be a slight modification on that API, an asynchronous msync, right? Which I think is interesting and important to upper layers. We talked briefly about higher layer application semantics. Databases and transaction libraries are doing this. The SNIA NVM programming library is one example. And even language compiler extensions. They've been talked about before, where languages and compilers can actually be memory aware and implement transactions in the language. We desire, bottom line, a broader engagement and dialogue with developers. I don't think we can start at the bottom and move up and have something compelling when we're done without that top-down discussion. So the goal is to provide these fundamental primitives at the RDMA layer that are useful all the way up the stack to applications. And finally, next steps. The consensus desire was to have some sort of coordinated discussion, right? Not to have a lot of little discussions that all somehow come together. The idea was to have this in a coordinated fashion. And we can certainly identify 4 groups right off the top of our heads. OFA for the interfaces and for the interoperability at the upper layer. IBTA for the Iraqi InfiniBand RDMA protocols and also some of the verbs issues. IETF for the same things in the IWARP space, SNIA for the APIs, and I don't know who else. There was no conclusion, however, on whether a single organization could shepherd this. So, watch this space. There's strong desire to have some sort of coordinated discussion. How we engineer that is still TBD. So, it was 2 hours long and it was great. Thank you everyone who came. I guess I have time for a brief question if there's a little more clarity needed. Okay.